here's my kind of go-to system of equations that I'm exploring today. Right, so I've got x minus 2y is 1, and 3x plus 2y is 11. Now, I want to think about elimination here, right? So what is your elimination step to solve this, like a la algebra?
Matrix 1.
Oh, damn it, I shouldn't have given you this one.
Yeah, I was like, this one works pretty well.
Okay. Let me do this the dumber way, just to illustrate what I'm going to do with matrices. So the dumber way is, I'm going to say, instead of just adding them together and getting rid of the y's, I'm going to target this 3. You guys with me? Okay, so I'm going to multiply the first row by 3 and add it to the second row. By negative 3 and add it to the second row. So if I was writing this down in algebra class, I would be writing down the new second row is the old second row minus 3 times the old first row. You with me on that? And in your case, you guys know what this little hat means, so I'll put little hats on it, and you can kind of think about it as vectors, right?
Yay.
Yay! Okay, so after doing so, I'm going to have my first row left alone, right? And what am I going to have in the second row?
0 plus 6y.
How many ones?
Oh wait, 6 minus, okay, sorry. So if that's 6 and you're subtracting from a negative, it'd be negative 8y.
Yeah, so let me do this the same way I do in algebra class. So I'm going to take this first row, right? I'm going to multiply by negative 3, and I'm just going to write it underneath here.
Yeah.
So if I take that first row and multiply by negative 3, it's going to be negative 3x plus 6y and negative 3.
Yeah.
Yeah. I mean, if you're multiplying...
That's literally just this times negative 3. And now I'm going to add,
Okay.
right? So I'm going to get 0 x's, I'm going to get 8 y's, and I'm going to get 8 on the other side. You guys with me on this?
Yep.
So matrix-wise, what just happened is the matrix equation 1, negative 2, 3, 2 multiplied by the vector xy equal to the vector 1, 11, right? And then something happened, right? And I got the matrix equation 1, negative 2, 0, 8 multiplied by the vector xy is the vector 1, 8. You guys with me on this? Okay. So now we're going to have to come up with a thing that does that.
Make the negative 2 0.
So I want you guys to figure out what goes in for question mark.
R1, vector R1 is equal.
Yeah, I mean, this is kind of the idea, right?
Yeah.
You guys see that? With rows, this is the idea.
Oh,
I want to think about that step as a matrix.
oh, okay.
You guys with me? Okay, so I want you to take the last 5 minutes here and experiment and come up with a matrix that does this. Okay, so let's see if we can talk our way through this. So, what we're seeking is this matrix here that has the action of leaving the first thing alone and subtracting 3 times the first thing from the second thing. The reason that I'm seeking that matrix is that that is this question mark here. Because the way I got from this first step to this second step was I took the first row and I took the first row, multiplied it by -3, and subtracted it from the second row. You see that? So I kind of have this idea, right, over here, about rows, and I want to make that into a matrix, so I can talk about using matrices the whole time instead of fiddling around with rows. You guys with me on that?
Yes.
So, Ricky says she thinks she knows the matrix that goes in here. So what are the numbers?
So 1, 0.
Okay, so let's check that. If I take this vector, pick it up, twist it, drop it sideways, I do indeed get R1. Check. Ricky got the first coordinate correct.
Yay.
Or the first row of our matrix.
Oh,
Okay, now, Arshia, has your brain just clicked enough to tell me what the second
No,
row is?
but-
Okay.
no, but
No, but you're with me now.
Yeah,
Okay.
I know, yeah.
So, what goes in the second row?
I have -3 and 1.
let's go.
Okay.
Oh,
Perfect.
yeah, that's,
You guys with me on that?
Yep.
So, what happened here was we took this equation and then to both sides from the left, we applied the matrix 1, 0, -3, 1.
yeah.
You guys see that?
Yep.
So this thing is what's called an elimination matrix. Because, uncreatively, it is a matrix that does elimination.
No way.
So we call it an elimination matrix.
Great.
Is with that?
Yeah.
Okay. So, that's giving me a tool to get from step to step. You're going to be asked for lots of these. Like, in the homework, there's a bunch of these questions where they ask, what's the elimination matrix for this stage? What's the elimination matrix for this stage? What's the elimination matrix for this stage? Like, I want you to have a way to answer that question. And one of the ways you can answer that question is you can look over here and think, what do I need to do from here to here? Right, like, if these were systems and I was doing elimination, what would this step be? Okay, I'm going to conjure that up as a matrix and write it down. Is good?
So the existence of an elimination matrix to me implies the existence of a substitution matrix, or is that?
No, sadly. That's a good idea. Unfortunately, the technique of substitution is just a little bit outside the scope here. Like, it doesn't actually fit with matrices very well. And so I don't have a matrix to cause substitution. What I do have is a matrix to cause permutation.
I don't.
So if the rows, I don't know if you guys remember this from an algebra class, but one of the things that can happen when you're solving an augmented system is it might be upside down, and you might need to rearrange things to get the identity matrix at the end. So rearranging is called permutation, right, in math class, because we're jerks. So there is such a thing as a permutation matrix that switches things. You guys have seen one of those matrices already. Do you know the permutation matrix that you saw already?
Like flipped over identity matrix?
Yeah, the identity matrix that's flipped over.
0, 1, 1.
So this guy, 0, 1, 1, 0, is a permutation matrix that flips the role of x and y, right? So what that's going to do is that's going to reorder your equations. You guys cool with that? Okay. There are kind of more ways to make a permutation matrix than this guy. They have the columns and rows of the identity matrix, but rearranged. That make sense? Okay, cool. This should give you enough to get started.